Okay, we are DroneHack, and this is our presentation. So the question that we were trying to address is this issue of the greening of the Arctic. We didn't incorporate this week data from the rest of the world, but there's greening going on all over the planet. And it's particularly prominent at high latitudes. But one of the problems is the satellite data sets don't agree on how much greening is going on. And if you go and look on the ground at data collected at sites around the Arctic, where we know there's vegetation change going on is not necessarily where you get the greening pixels in various satellite data sets. So maybe drones are the answer to this issue. Maybe high-resolution data can help us figure out where satellite data sets are not agreeing. And maybe the Earth engine is going to take us there. So that was our hackathon here. And so these are the preliminary results. So what we have here are two raster images of the difference between Sentinel data and Landsat data NDVI to satellite-based NDVI. And these red grid cells are where the drone data are higher than the satellite data, and the blue ones are where the satellite data are higher than the drone data. And then we have these predictor variables we can compare to that difference between the NDVI data. So we have the RGB imagery collected by the drones. We have an elevation model created off of the drone data, and we can calculate various other things, like, in this case, spatial autocorrelation. Thanks, Aaron, out there, for giving us the code to do that. And so I'm going to pass it over to Connor to explain our workflow.
Sure. So I guess what we were trying to work out is that if we have some drone data, we have some existing Landsat and Sentinel data, and we can see where they're not in agreement, maybe we can train a classifier to apply to other areas that aren't covered by drone data, and use that to work out where are the areas that we would get the most bang from our buck by sending our drones to. And so we have we have the drone data here. We've got like an area of interest. We've generated a whole load of points, and for each of those points, we're getting like the elevation information that we might be able to get from other sources. We've got the Landsat data. We've got the Sentinel data, and we can build a classifier then that takes all of that information, takes kind of elevation and things like that, and that can be used to produce kind of a very peppery, spotty image here, but maybe with some post-processing, this could be used to guide where we would send the drones to get the like really valuable information that we're not getting from Sentinel or Landsat in some circumstances.
Sweet. So just to visualize that here, those red areas where you have, say, the higher, I think that's the higher satellite data versus the drone data, or vice versa, might map onto different properties of that landscape. And once we can explore those algorithms at specific sites in the Arctic, we should then be able to scale that up to the entire Arctic. So I'm going to pass it over to Shannon to finish us off here.
Hello. Okay, so this is the preliminary app that we built with the help of Lauren. So thank you, Lauren, wherever you are. So as you can see, we have the different data sets. So we have the Landsat data, Sentinel data, the RGB data, just as like reference, and drone data represented. And then these are at the same zoom scales, but you can see the Landsat and Sentinel data are much lower resolution than drone data. So when you would click on the Landsat data, the drone data would show you in that area. So future directions for this app would be, one, to turn the hand clicker into a cross clicker, because I couldn't get that to work. But also to apply this this same setup to different areas where or drone data has been collected, to give researchers like a better idea of where those differences might come from and what areas that they're using Landsat or Sentinel data, which especially in a specific spot might be less accurate than they would a drone, like which areas are more likely to have the bigger differences.
Great. And then this idea would be that we can then scale these algorithms up to the circumpolar Arctic and start to understand why these satellite data sets don't match up. So thanks, the members of the DroneHack team. Thanks to our Googlers who helped us along the way. And let us know if you have any questions or if you want more information.
Excellent. Thank you all. Take that. Oh, questions. Any questions? Yes.
Any lessons learned for uploading or importing drone data to Earth Engine? Tips?
Good question.
It's gone pretty smoothly so far, so great work, Earth Engine team. Yeah, so just upload as an asset these data we made public. Yeah, we were trying to push things so we could see if anything broke, and it didn't. So yeah, thumbs up.
All right.
Another one at the back, or I don't know if we're out of time. Same question. Awesome.
All right.